For those of you that are in attendance, thank you for coming today. I've been looking forward to building a series of topics around AWS resources for a while, and this just happened to be a good time to do that. We missed, I guess, the cybersecurity month by just a few days, but this seems like a good, appropriate topic to bring up anyway, given what's going on in the world of security and cloud computing. So without further ado, we'll get this ball rolling. A little bit about Sunset Learning. We've been helping customers deal with their technical training needs since 1992. We became an authorized AWS learning partner at the beginning of this year. And so we've been really doing this for almost, well, over 20 years at this particular point. So quite a long time working with different vendors, et cetera. And we can build some custom learning paths or those types of things, whatever you really feel comfortable with as far as addressing your technical training needs. So today, we're going to be talking about how do you use AWS to secure your accounts, or how do you use, identity and access management for securing your AWS accounts. And we'll start with a review of key security tenets. We'll go through some general AWS security best practices, which really could be applied in any situation where you're dealing with security. We'll talk about the AWS shared responsibility model. That's oftentimes misunderstood or not understood at all by AWS customers. We'll talk about the tool itself called AWS Identity and Access Management, or IAM, or I call it IAM. And we'll talk about some best practices with that tool. So why are we having this conversation to begin with? Well, it's pretty straightforward. There probably, when you look at it, it doesn't matter whether we're talking about cloud technologies or we're talking about on-premises based networking and application configurations. Most security breaches are as a result of a lack of proper configuration of resources, or what we'll call misconfiguration of our different resources. And some of them have to do with networking permissions. Others have to do with overly permissive permissions that we give to users or applications accessing our resources. And that's really what these quotes from different vendors and industry analysts are talking about. A significant number of breaches are, especially with cloud technologies, and that's cloud vendors, whether they're AWS or Microsoft Azure or Google Cloud or any other of the 200 plus vendors that are providing cloud-based services. The biggest threat to them are really misconfigurations on their side that allow the bad actors out there to gain access to their resources. So I do have a list of and links to these different articles. You might remember the security breach that Capital One had in 2019. They were on the AWS platform. And really the crux of that breach was due to, again, customer misconfiguration of resources on that cloud platform. So just something to keep in mind as we go through here. When we talk about security, it's always a good idea to just review what the key security tenets or what security practitioners think about the most. And one of the first things we think about, of course, is confidentiality. How do we protect the data and applications that we're responsible for from unauthorized disclosure or use or access? And furthermore, if we're responsible for storing information in the cloud, whether it's data or whether it's applications that act on data, et cetera, how do we ensure that that information that we put into the system doesn't get changed or damaged in one way or another? That's really what we refer to as integrity of the information. So confidentiality deals with making sure that we only the people who need to see that data see the data or are able to use the applications. Integrity deals with how we ensure that the data or applications haven't been altered in any way or damaged from when we put them in. And availability deals with the idea that the application or the data that we put into whatever the system is available when we need it. Now, we do these, we affect these tenants in many different ways. In this particular discussion, we're talking about people or applications being able to access data or other resources that we put into AWS. And the way we allow access is, first of all, by verifying the identity of the users, applications, or whatever devices they may be using through the process of authentication. So prompting for usernames or passwords, or maybe an ID and a security key, or any of those other credentials, security credentials are important there. And once we authenticate a person or an object into the system, could be an application. That's why I'm not tied 100% to just talking about authenticating users in this particular case. Then we have to authorize that person or that application to use resources that we happen to have. So those are kind of the key principles that we're going to be talking about as we go through and we talk about the AWS Identity and Access Management tool today. Now, as we think about those things, the confidentiality, integrity, availability of our data, and how we authenticate and authorize folks to use those resources, we need to think about the AWS security best practice recommendations. And the ones I have highlighted here in gold or yellow are really, I think, the ones that are applicable, most applicable to what we're talking about today, although all of these arguably could be applied to what we're talking about. And the first thing is, if you're going to authorize a person or an application to access resources within your AWS environment, you really only want to give them the privileges they need to do their job and no more, right? A very significant number of security breaches happen from inside the organization. And oftentimes those security issues that come up happen because a person, number one, they happen because oftentimes because they're accidental. And number two, because the person who affected those problems or created those security issues had too many privileges in the system. So we want to make sure people only have the privileges they need to do their job. Secondly, we need to know who did what to what resources when. So we need auditing to be enabled. Defense in depth is an interesting concept and principle that we follow in security land. And it simply has to do with putting multiple layers of defense in front of our resources. Think about that from the perspective of, I don't know, an everyday thing like driving, right? Maybe you chose to drive an automobile versus a motorcycle because having all that extra metal around you gives you a layer of protection you don't have on a motorcycle. Further, you decide to buckle your seatbelt because if you are involved in an accident, the hope is that you're not ejected out of the car and further damaged by that accident. And thirdly, most modern cars now have airbags, right? So you have a third layer of defense if you're actually involved in a serious car accident that those airbags will deploy. So you've got the metal of the car protecting you. You've got the seatbelt, you've got the airbag, you have multiple layers of defense. And the same is true when you're storing data or running applications, whether it's in a cloud provider's environment or whether it's on premises or whether it's at your own house. You need to figure out what layers of defense you're going to put in there to manage those tenets of security we talked about, that confidentiality, the integrity, and the availability of that information, right? So we talk about defense in depth as that concept of putting multiple layers of defense out there to protect our resources. And then this idea of minimizing attack surface. It really varies depending on what we're talking about with regard to where we're protecting our things. But when I think about that in terms of account management and identity management, what I think about is not having everybody in the organization having administrative access or administrative privileges to my resources. So I want to create, if we were talking about networking resources, we create a choke point somewhere on the network so everybody has to ingress and egress out of a smaller area in the network. When we're talking about people and objects accessing our resources, we want as few of people being able to access those resources as necessary, but still give the people who need access permissions to do that. So those are kind of the key principles that we talk about with best practices. Of course, encrypting the data certainly helps us with confidentiality and also with the integrity of the information to a degree. This preparation for security events is important. if your resources are breached in any way or compromised in any way, you already want to have a response to that. Think back to that Capital One breach in 2019 of credit card information. The way they responded was entirely proper. The problems will occur, people will make mistakes, and misconfigurations happen. How you respond to a security event or an incident is important. So you have to prepare for those. And automation is a double-edged sword. When we talk about things today, we're going to be talking about things that are about misconfiguration and people gaining more access than they should to resources because we gave them too many permissions. You can make that worse if you then automate or proliferate those policies that allowed those breaches automatically. And some organizations use those tools. You can also, however, use automation to mitigate issues caused by human error. So you want to use automation to your advantage, but you want to be careful how you use it. Okay, so those are kind of things to think about, key items to keep in mind. Now, as we move along in here, one of the things, and I might refer back to the Capital One incident multiple times, because it's important to understand that AWS has something called the shared responsibility model with regard to how people access and use AWS resources in the AWS cloud. And AWS promises through the shared responsibility model that they will be responsible for all of the physical hardware, including computers and storage resources, networking resources, data centers, et cetera, that support or provide for those cloud resources that are exposed to us as customers. But what we're responsible for is anything that we put into that cloud. So AWS says, hey, we're responsible for the cloud itself. You're responsible for anything you put into the cloud. And that includes making sure the operating systems are patched and up to date and protected against attack, encrypting any data that you happen to have there, protecting that data integrity that we talk about. But it's also, we're also responsible for any of the configuration that has to do with who we allow access to those resources. And so that's what our conversation is about today, is really focusing on this top level of identity and access management, right? Who has access to our resources? And as we have that discussion, again, we're going to go back to this idea of authentication and authorization. Are those people allowed to access, or people or applications allowed to access our resources? And that's done through authentication. And then what are they allowed to access and how can they interact with those resources? That's the authorization component that we'll be talking about here. Okay. And this service called IAM, or Identity and Access Management, does both of those things. But before we get in there, let's talk real quick about the components and the pieces that are necessary here. And I apologize in advance. This is kind of an eye chart here, and there's a lot going on in this picture. But what we'll notice here is when you go to AWS and you create an account, the first thing you do is you provide a username in the form of an email address, and you create a password, hopefully a strong, hard to guess password. And you then provide some sort of payment information to AWS, typically a credit card. In exchange for that, what AWS gives to you is a 12-digit account ID. And that account ID becomes your little container for resources and where you create and instantiate users and other items within the AWS cloud. Okay. So what we see here is we can have more than one of these accounts. If our organization is larger, if we're a smaller organization, we may only have a single account to manage. If we have multiple accounts, we'll manage those accounts using something called AWS Organizations, and we can centralize the management of all of our account resources. And we can put guidelines and policies in place to manage those. We can do centralized billing and those types of things. So an AWS organization really defines your footprint within the AWS cloud if you have multiple accounts. If you only have one account, then your footprint is really that account. And let's dive into the account a little bit. Within the account, we create resources. We create users, and we create these things called roles that we'll talk about. we decide who has access to our resources, okay? And with that in mind, our resources really are those things that, that we create within the AWS cloud, like servers and storage containers and databases and any other applications that we may launch or host in AWS. And we manage who has access to those resources using policies or policy documents. Okay, so as what we see here in this diagram is we see that these principals or users, maybe we'll call them for right now, could be an application, makes a request to access some resource. These are the resources down here. AWS then has to, number one, verify that that user is who they say they are. That's the process of authentication. And then we need to check against a policy or a series of policies to see what that user is authorized to do, or verify, number one, when they make that request, that they are authorized to use that resource that they're asking to use. If that works, if they're authorized, we give them access. If not, they're denied access. It's that simple. So that process of, is this entity who wants to gain access to my resources real? Yes. Do they, what access is the request that they're making to access those resources allowed or denied? Yes or no? Okay. That's really all we're talking about today. It doesn't sound too complicated, but this is where 60 to 75% of misconfigurations occur in AWS land and in cloud, in the configuration of cloud resources in general, regardless of the vendor. So that's why it's an important topic to talk about. Now, in AWS land, the people or things that have access to our resources are identified as principals in these policy statements. And we'll talk about policies in just a bit. But those people include users, something we're going to call roles, AWS services. You can have an AWS compute service that needs to access other AWS services like a storage service, and you need to provide authentication and authorization for that to happen. We can also have folks that don't have a user-defined set of credentials within AWS access our resources that we have in AWS. Think about an app that you devise on your phone that you've created a backend application for in AWS land. Maybe it's a banking application or something of that nature. Those users don't necessarily have a login account in AWS land. Maybe it's a social networking site. Maybe they authenticate through Facebook or Google or something like that. We can set up a trust relationship between that identity provider, AWS, Google, or Amazon, Google, Facebook, whoever it may happen to be, with AWS and our resources within our account so that they can access those resources using other sets of credentials. So that's what we mean by a federated user. Okay. So we've got folks that we're going to authenticate and then authorize to use our resources. Let's break that down a little bit. When you first set up that user account in AWS, or when you set up that account in AWS, and you provided that email address and you provided a password, and AWS responded and said, okay, here's your 12-digit account number. What they did for you is they made that email address and that password into something called the root user. And that root user, by default, has unlimited power within the account. I won't apologize for the graphic. I thought that was one of the first things I thought of as I created the root user slide here, is this user can do anything they need to within your account. That means create users, create resources within AWS, but also delete or compromise those in any way necessary. So that user has unlimited power. It is the default account user, not unlike the administrator user under Windows or the root user under Linux. Okay, that user has unlimited power. And we don't typically use that user to do day-to-day administration, right? We create an administrative user. That's one of our best practices. And we give them limited permissions to do what they need to do in the account. We then secure the root account and lock it away. In AWS land, when you create a user, you can give that user, or the user will automatically have a username and password that's associated with them. You can further enable other security credentials on that user using multi-factor authentication. Those users can also programmatically access things or access things from the command line. So you're given the option to create special keys for them to use at the command line or programmatically through applications. The root user should never have those keys associated with them, because you can see if those keys were compromised, somebody could programmatically over the network access all of your resources and compromise your environment. Okay, so we lock away the root user, and we allow it that we only use that root user when we absolutely have to. There are some things that only the root user can do within our accounts. Okay. Instead, what we do is we set up these users, these IAM users, and they will have associated with them their own access credentials, username and password. You can turn on multi-factor authentication, so they have to provide a token, a third piece of information to be authenticated into the system. Note that it says here, these are not separate accounts. They're users within our account. Okay, so we're allowing them to access to resources within our account. So the best practices here is you set up these users. For instance, I'm going to use my root users. It's set up an administrative user. And I'm going to say, what should that administrative user be able to do in my account? And I'm going to follow that principle of least privilege that says only give that user, that administrative user even, access to the things they need to do their job. Okay. And I'll use that user for their day-to-day administration. Further, I may make that user a member of a group. Okay. Now, what's a group? Well, a group is just a collection of users. And the great thing about creating groups is I can assign permissions through policies to groups that when I put somebody or make somebody a member of a group, they inherit the permissions of the group. What that does for me is it means I don't necessarily have to create individual permissions for every user that I create in my AWS account. I simply assign those permissions to those users. How does that benefit me? Well, in this particular case, I may have a user who comes in as a member of the developers group, but later that user may move over into the security team. Well, if I had granted permissions to Susan, let's say, who came into that group individually and said, okay, here's all the permissions developers need. Let me assign those to Susan individually. And then Susan decided to move over into the security team. Then I would have to take away her developer permissions and give her security permissions. That's hard, and it's not good for a lazy administrator like me. What I'd rather do is assign permissions through policies once to the developers group, the security group, and the admins group maybe over here. Then as I move people between those different groups or somebody leaves the organization, I can simply, those people just inherit the permissions of the group that they're moved to. Or if they're moved out of the group, they have no permissions associated with them at all. And that's the beauty of AWS. When you create a user, that user has no permissions associated with them at all. They're just a user. They can authenticate, and then they can't do anything until you give them permissions to do things. They get permissions through policies that we'll talk about in a minute. Okay. Now, there's a special type of entity within AWS that you can create beyond users and groups. It's called a role. And there really is a reason for this goofy picture. A role is something that you set up and you give permissions or authorization to do different things within AWS to different resources. Then you can trust a user or a service or an application to assume that role, and they will inherit the permissions that that role has been associated, that have been associated with that role. So how this works is, let's say that you had Susan, right? And she's a member of the developers group, but occasionally she needs access to resources in the test group. And all the test folks are on vacation. What Susan can do is she can assume a role in the test organization that you've created that has all the permissions that the test group needs. She can assume that role. She gives up her permissions as a developer, and she assumes the test role. She can execute the tests on her application that she needs to. And when she exits that role, her permissions revert back to her developer permissions. So these are temporary permissions. Let me show you how that might work. Here we have an account that's set up. This is my AWS account. I can do a lot of different things in this account because I happen to be an administrator. Here's a list of my users in here. Over here, you can see that this is my account. You can see my 12-digit account number here. And I can assume a role in another account, okay, to be maybe the administrator of that account. When I'm done doing that administrative work in that account, I can simply go back to my old role, okay, as administrator of this account. So roles allow you to temporarily assume authorized activities over other resources. And then when you're done with them, there is a timer that's set. There's a default timer, and you can change the parameters behind that. Those permissions will either time out, or you can manually revert back like I just did here, okay, to exit that role. So a role is a special tool within AWS, a special principle, if you will, that you can assign permissions to and take and assume so that you can have temporary access to those different resources. Okay. Now, this is where folks get into trouble. When they set up these, where they go, oh, cool, roles are cool. We can give our application roles or access to different things using roles. And we don't have to worry about passing things like secret keys and things over the credentials for authentication over the network when we start using roles. And that's a positive. The bad news is folks forget that a role acts like a user or a group within your organization. And you have to follow the principle of least privileges when you're assigning these role policies, or people may have too much access or even escalated access to resources when they assume these different roles. Okay, so you have to think those through very carefully. That's where some of the large breaches have occurred in AWS land from the customer side of things. So how do you contain those capabilities of those users, applications, or roles that are being used here? You use AWS policies. And there's a couple of different types of policies. There's more than are listed here, but we're going to talk about these two. We have identity-based policies, and those are policies that we attach directly to users or groups or roles. And those policies provide the authorization to do different things to AWS resources. We also have something called resource-based policies, and those are policies that we associate directly with AWS resources, or things like compute and storage and database, or other types of services within AWS. So you can either have resource-based policies, or you can have identity-based policies, where somebody has both an identity-based policy and a resource-based policy that applies to them based on what they're trying to do. The one that is what wins is the least, I should say, the most restrictive policy will win there. So AWS provides a number of policies. Probably the easiest way for me to illustrate this to you is go in here and show you how they work. If I create a user in AWS land, let's see, I always use Alice, Bob, and Mary when I'm talking about security. We've done that for years. So we'll create a user called Bob, okay? And AWS is going to ask us, maybe you can't see this too well, so let's blow that up a little bit. AWS is going to say, hey, what type of access type should Bob have? Notice we have the ability to choose an access key or a password, okay, or both, okay? And in this particular case, I'm going to go ahead and choose both, because Bob may have to interact with resources on the network through the command line or using his applications that he's creating, because he's a member of the developers group. He also may want to interact with applications using the console or this particular tool that we're looking at here. So I'm going to give him both username and password credentials, as well as generating an access key and a secret access key so he can programmatically access AWS resources. Well, that's cool. Now, what kind of password do you want to give Bob? Well, I'll give him a custom password. Let's see, I'll give some goofy password here, all right? And notice if I try to give Bob that password, it says, yo, dude, you can't use that password. That's not secure enough. So you must follow these standards. Okay, so I'll follow the security standards and see if I can create a password. Okay, and as soon as I do, you notice it turns from red to blue, tells me that things are good, I can move on. Okay, should I require a password set when Bob logs in? Yeah. Okay, so the first time Bob logs in, he'll have to change his password. Okay. The next thing it says then is, would you like to add Bob to a group, or would you like to explicitly attach permissions? If I attach permissions directly, those are Bob's identity-based permissions, right? And if I choose that, I can say, well, Bob, yeah, Bob is going to be an administrator in my account. Well, what permissions do administrators have? They have all access to everything. Now, this is a permissions policy. It's written in the JavaScript object notation language. You don't have to worry about that too much if you used what are called AWS managed policies. You simply select the policy. AWS applies that policy, and it may include many other permissions within that policy to that user. Those are managed permissions that you can associate with a particular user in AWS land, and you have a lot of them to choose from. Okay, so I like AWS managed permissions because as AWS updates services and creates new features and whatnot, they automatically update these permissions policies. You can also create permissions for users in a custom manner. You can build your own permission set, and those are called customer managed permissions. Or you can associate permissions directly to a user as part of their properties, rather than using managed permissions or customer managed permissions. I don't recommend that because those are hard to manage. And unless you absolutely need to do that, maybe for a particular application where you're getting very granular to just the little pieces of permission somebody, that application needs to do its job, I'd say, hey, choose between AWS managed or customer managed. Those are both reusable. So if you're applying those to groups, right, instead of individual users, you don't have to worry about assigning them individually and maintaining them individually. Okay, so let's look at that. I can create policies and attach them directly to that user, or I can go down, I can just assign Bob to a group where I've already added permissions. And maybe Bob's a member of the SLI demo group, okay? And it looks like as a member of that demo group, he can assume the EC2 role. Well, that might be useful, right? Okay. The next thing we'll do for Bob is we'll put a tag on Bob so I know what to do with Bob later. Okay. Normally you would use something like department name, or whatever it makes sense to you as far as setting up tags for your users. Tags become very important in AWS land because they help you monitor and manage things. They help you document things, etc. So it's useful. So here we got Bob set up for programmatic access as well as console access. In other words, username and password, secret keys. Okay. And we're forcing Bob to reset their password. Okay. That's the IAM change password summary that's going on here. And the tag is delete me. Okay. When I go to create this user, I'll be prompted for one more thing, and that is saying, hey, you gave Bob a secret set of credentials so he can programmatically access resources in AWS land. Okay. What do those keys look like? Well, they are access credentials that you can download. Okay. You want to treat these just like you would your credit card or your username and password to your bank account. The access key from a programming standpoint or for the command line acts as your username, and the secret access key acts as your password. Okay. Well, you can send email login instructions to Bob. That won't send the key over the mail, but it will let Bob know he can click on a link and access AWS in this account, this 12-digit account that you've created, and then he'll be forced to change his password, etc. Okay. So Bob has been created. Now, if you don't take a copy of those keys at that particular point in time, you will never see them again. So you can delete keys, but you can't go in and look at them after you navigate off that page. Okay. But there's Bob. We've created him. We'll go ahead and delete him now just to make sure that I didn't do anything silly through this demo, and Bob no longer exists. But also, I left some pieces in my account here so that you could see this. I've got this user called M. Kutzer. And if I look at that user and look at the properties of this user, the first thing you saw was he hasn't, let's go back to that just real quick. The first thing you see is that Mike here hasn't accessed that account for 135 days. When you see things like these are bigger than yellow flags. They're probably red flags that say, hey, maybe that user doesn't need to be in my system. Minimizing the attack surface, right? But let's look further into this user because I think it is kind of interesting to look at. There's another auditing tool within AWS here called the Access Advisor. And one of the things under IAM, the Access Advisor does is it tells you what permissions this user has and also when they were last accessed. So this user was apparently involved in a project about 185 days ago. And part of that project was to set up a AWS contact center environment. And he used these different resources. But you'll notice there's 29 pages of other permissions that this particular user had. Okay, so that did not really follow the principle of least privileged access for that user either. He didn't even use any of these permissions that he had, yet he had all access to all of these other resources within AWS. Okay, so a good quick way to look at what permissions your users have, what they have access to, et cetera, is look at that first page, see when they last access things, use the Access Advisor within IAM to see what that user had access to and when, right? That's one thing you can do. You can also use a tool called Access Analyzer from within IAM. And what Access Analyzer does is it tells you about all of the resources that may be accessible outside of your account or trusted with external users. In this particular case, we've got a federation type of a setup with providing SAML authentication. In this particular case, I happen to know what it is. It happened to be providing single sign-on for folks in a Microsoft Windows Active Directory domain. Okay, so I trust that one. I'm okay with it. But if you see things in there, this Access Analyzer has been added fairly recently as a feature of IAM for AWS for you to use to audit and see what resources you're trusting to external entities. Okay, so just wanted to show you a few things so we can talk about those as we go through. Types of policies. You have those that are managed. AWS provides those for you. They're reusable. They're packaged and managed by AWS. Customer managed. You can actually copy AWS managed policies that you know work and modify those to create custom policies, or you can write them from scratch. Inline policies are those associated directly with an object. I don't recommend them for setting up for users and groups, but it's the only type of policy actually that you have when you're putting policies on resources. Okay. Now, what does an identity policy look like? Well, you can see from this particular policy that we have a version number, and then we have some key pieces. We have the effect, and the effect is going to be an allow or deny, okay? Then we have an action. What actions can this particular user take? You saw that Mike had a bunch of actions he could possibly take on a bunch of different object types or resource types within AWS. In this case, we also have something called the resource. So effect, action, and resource are kind of required in our policies because they tell us, is somebody allowed or denied the ability to do some action on what particular resource? In this case, it's pretty wide open. It says this particular identity Bob, is allowed to start and stop EC2 instances. Which instances? Any instances. Beware of the asterisk, okay? But the good news is he's only allowed to start and stop EC2 instances that he created or he's the owner of, okay? And that's just how it works. These variables are, and these are keywords within AWS, are set up in such a way that one of the things oftentimes you don't want the test folks shutting down the developers' servers out there. And an EC2 instance is a server. So what you'll do is you'll set up policies that say, hey, only the people who created those servers should be able to shut them down, maybe. Okay, that's what's going on here. So what you'll notice is in here is we have the effect, we have the actions, we have the resources that are impacted by those things, and we may or may not have conditions that say, hey, these folks are only allowed to access this storage bucket between the hours of 8 and 5, Monday through Friday. You can do those kinds of things in AWS land. Make those as restrictive as possible as you set those up. We also have something called resource policies, where instead of applying policies directly to a user or group or a role, we can apply policies to resources. In this particular case, we've got a storage resource called an Amazon S3 bucket, or the simple storage service bucket. And again, we have our friendly version number that we're not going to mess with. That just tells AWS what policy engine is going to be able to process this particular statement or policy statement. Within the statement, all the familiar stuff, right? Statement ID, we've got the effect, we've got the action, and we've got the resource. But wait, we have a special thing here. We didn't have the idea of a principal in our identity-based policy because we know who the principal is. We're attaching that policy to somebody, Bob in this case. In this particular case, we have to specify Bob, or again, this means everybody or everything, right? The asterisk. So be aware of the asterisk. It says, hey, we're going to deny everybody all actions on our S3 bucket. Let me erase that so you can see it. The S3 asterisk means all actions on S3, okay? But not just any bucket, just all S3 actions on this particular bucket and these particular files within the bucket. Well, it's the demo bucket and all of the objects stored within that bucket. But everybody is denied access except folks coming from this particular network address, okay? This happens to be a public address and a public address space, so I'm a little bit worried about it because that's that's 256 addresses that potentially have access to that particular bucket, okay? And it's accessible over the internet because that's a publicly routed address. So maybe it's a bad example, but that is kind of the effect. What I wanted you to see is effect being allow or deny. I wanted you to see that resource policies have principals who can access me. Actions, what can they do? What actions can they perform on that resource? And what is the resource, okay? And you can see that you can add conditional statements to that. Okay. All right, let's keep moving forward. How are those policies evaluated? Well, if we have an explicit deny statement like the one we saw, they will be denied. But we had a condition there that said, except if they are on this particular network. Okay, so they were allowed based on that exception. Are they explicitly allowed? Well, if they are not explicitly denied, and that's what AWS does first, is it goes through and it says, are there any deny statements in the policy? Let's process those first. If they're not denied, if their request itself is not denied, let's see if they're allowed. If they're allowed, right? If they're not explicitly allowed, they're going to be denied anyway, because at the end of the policy statement, there's always an implicit deny. You don't see it, you can't smell it or hear it, but it's there operating for you. And that just is a safeguard so that people don't have excessive, they can't defeat the policy by putting excessive statements in there. Okay, so We already looked at this. We have different ways of keeping track or monitoring AWS through the IAM tool itself. In that IAM tool, we also have the ability to run something called the credential report. You can get a listing of all of the usernames, passwords, and the disposition of those accounts in a nice Excel spreadsheet that you can download, or a CSV file that you can download. Okay. There are other tools available for you to do monitoring in AWS land with. One is called CloudWatch. It really monitors all of your metrics for different resources that you have. But if you see excessive usage going up on a particular resource at a particular time of day that shouldn't be happening, you can go down and you can say, I wonder why that is happening. Let me look at the CloudTrail logs. The CloudTrail logs show me all accesses to APIs. And in AWS land, what you need to know is there's over 200 services that AWS provides that you can grant permissions and authorization to use. AWS by default monitors access to any of those services because all those services are exposed to us through that console or the command line or AWS software development kits as well-known application programming interfaces. So we track through CloudTrail all access to those APIs. Who did it? When did they do it? What API was it? Okay, so we always have that information available to us if we need it. And we can actually send those logs to CloudWatch and have CloudWatch alert us if certain things happen that we don't like. Okay, like somebody shutting down servers or starting up servers in the middle of the night. That might warrant a alert to us. Okay. I also keep track of billing and things under the billing tool in AWS. It's a way to set up budgets and thresholds for different things. So if somebody, remember, one of the beauties of the cloud and AWS in general is to be able to pay for resources as you go and instantiate those resources very quickly if you need to. So you might build servers in AWS as part of your R&D work, or for us for training work and other things. That's a great thing. You can do that on demand and you pay for those things as you use them. But what happens if somebody compromises your account and starts creating these things, spawning them for doing cryptocurrency mining or things of that nature? You'll want to be aware that that is happening. You can do that by monitoring your resource metrics. You can look at those through, you can investigate further by looking at CloudTrail logs. And you can also get notified that, hey, all of a sudden you had set a budget for, $1,000 a month or whatever, and you're already at $10,000 a month. Something bad happened. You can see that through these different tools if you're monitoring AWS. So bottom line, let's look at some big picture of things that we talked about. I know that's a lot to unpack in 45 minutes or an hour or whatever we had here. So I'm going to try to summarize this real quick and point you to some next steps. When we create an account in AWS, we're responsible for securing any resources that we put in there. So that container that we create to put those resources in is called an account, right? Or our account. We also create these things called principals, IAM users, groups, roles, etc., within that account. And we provide those principals access to resources using the IAM tool. Okay. By default, a user, when you create them, has no permissions to anything, just has a username and password or other access credentials, right? So we have to explicitly provide those permissions to the user, either by making them a member of a group that already has those permissions or allowing them to assume a role to be able to access those permissions. And those permissions are granted through policies, either on the individual user, the groups, or the roles, or by virtue of the fact that we've set up policies on the resources themselves. When you have a combination of those two, where a user has some permissions and the resource has some permissions associated with it, and the user goes to use that resource, the most restrictive permission set wins. Okay. We need to keep track of how people are using those resources, and even the entities or the principals themselves, like Mike, to make sure that they're actually active in the account. If they're not active, it's a vulnerability to us and we should remove that user from the account, right? So that's what we use the different monitoring tools for. We also use monitoring for looking at anomalies and different things that are going on out there and tracking those down and doing things about them. Okay. And before I terminate this discussion with some review of the best practices, let's just remember that we have that root user that's automatically created for us. And we really want to make sure that we use that user to set up those administrative accounts and then allow the administrative user that we created to do all of the other day-to-day activities like setting up groups and creating IAM roles, associating those with policies, and setting up our resource policies, et cetera. Let's lock that account, that root account away, except for when we absolutely need to use it for certain things, okay? So from a best practices perspective, here's a little summary. Can't say it too many times. Secure the root account. And remember, when we set up that user, Bob, we created some keys for that user so that he could programmatically or through the command line access AWS resources. And as you become more advanced with AWS, doing things through the console can be a little bit clunky and slow because you want to automate some of those actions. So you sometimes want users to have programmatic access. Certainly Bob, if he's a member of the development group, we may want him to have access to be able to do that. Mary, who's a member of the accounting group, we probably don't need to generate those keys for that user. You can create keys for the root account as well. You should never do that. Never, ever, ever do that. Because if somebody compromises those keys, they can take free reign of all of your resources in your account. Okay. Again, create admin accounts for day-to-day administration. Use, set up, and enforce multi-factor authentication for the root user and for any high privilege users, administrative users. You can do it for all users if you want. It just means that they have to provide additional credentials when they're accessing things. And that can be a little bit cumbersome for applications that are trying to access resources within AWS. Okay, good for users though. Use groups and roles versus assigning permissions explicitly to users. Yes, use identity-based permissions, but assign them to groups rather than to individuals. That way it makes the individual user portable across different groups within the organization, okay? And you don't have to worry about assigning and de-assigning permissions on an individual basis. Do it on a group basis. Where you want to grant somebody temporary permissions to things, use roles. Just don't make those roles overly permissive, right? The permissions that are associated with them, okay? Always practice least privileges, okay? As far as being able, and practice the concept of least privilege access where you're not giving people more permissions than they need to, okay? Don't share access credentials. We see this a lot. We see administrators going, this group of people, say my group, the instructors, they all need access to the same thing. We'll just create one user. We'll create one set of passwords and usernames for that user, and we'll let everybody in that group use those. That's not a good idea. First of all, we don't know how those users are going to protect those credentials and who they're going to give them to. But secondly, when we're monitoring or auditing things using CloudTrail, if we give everybody the same credentials, we can't tell who did what when. For every user that should have access to your resources, they should have individual credentials. That way you can track who did what when they did it, how they did it, what they were accessing, and what their permissions are, right? And not everybody needs the same set of permissions. Okay? Everybody wants admin permissions. They don't need them generally. Those access keys that we talked about, in addition to your username and password, you may have an ID and a secret access key to access things through the command line or through the software development kit. You may have to give those to your users, especially developer type users, and even grant those types of keys to your different services that you might be using. Roles are a good alternative for that for services, say an EC2 or a compute instance accessing storage. Okay, but if users must absolutely have to have keys, you have the ability in AWS to set up a rotation policy. And there are some very good white papers in AWS land to show you how to automate the process of rotating through those keys so that you can set up a policy that says rotate the keys every 30 days, every 10 days, every 90 days. You decide what makes sense for your organization. Do that. Change passwords regularly, make sure they're hard to guess. Use multi-factor authentication, of course, where it's necessary. Monitor the activities of all of the resources in AWS. And I have to tell you, one of the statements on that first page that we looked at where the industry analysts and different firms were doing exploration and penetration testing and that type of thing into different cloud accounts. It was Palo Alto Networks was commissioned to do some penetration testing on a particular customer network. And in very short order, that particular group of folks was able to find a role that was set up with overly permissive permissions that were using the asterisk, right, to say, hey, when we're using flow logs, which watch network traffic, developers have all permissions to those flow logs. Well, one of the flow log permissions is administrative access. And so they were actually able to escape their little account where they were bound and people had a high level of security set up so they couldn't get out of their development environment. They were able to escape using that flow log permission because somebody had set that up using an asterisk saying everybody has access to all of these permissions in flow logs, when generally a flow log that is managing and monitoring traffic on the network should be much more restrictive than that. So beware of the asterisk. Can be used many places to make your policies shorter, and it's very convenient for developers to use for testing purposes. It's a bad idea from an administrative standpoint. When in doubt, spell it out is kind of a key security word that we use. Don't use wildcards. Okay. So that's my little summary of best practices. I think we've been going for about an hour. Does anybody have any questions or comments or concerns before we sort of start closing this thing down? What do you do next? If this was your first introduction to AWS, it's probably a difficult one. I'd say if you're first getting started with AWS, probably what you want to do is you want to consider looking at the Cloud Practitioner Essentials class. That's where we kind of go through the breadth of AWS stuff in a very non-technical manner, so you kind of understand what AWS is all about. As you move through there then, and you're moving up, maybe you're a more technical person, you might take a look at our Solutions Architect course, which is a 3-day course that takes you through some of the technical details of how to instantiate these services that we're talking about, but it also gives you a bigger picture about network security as well as account security and those types of things. If you really get into it, then there are a couple of security courses down here. There's a Security Essentials course, which is a short 1-day course, but there's also a longer course that goes into great and gory depth on how to manage security, not only at the account level, but also through the networking level. Okay. And I think probably our next tech talk will probably do something about network security in here to complement this one. I appreciate everybody coming and taking an hour out of your day to listen to me talk to you about this. But remember, account security is one of the most important things you can do to ensure that folks don't have unfettered access to your resources, because the cloud changes everything. When we were on-prem and we had our resources on-prem, we had one egress and ingress point, or maybe a few, but we have a minimal number. In AWS land now, where you're putting your resources in the cloud and you have millions of potential attackers out there who can get to your resources, and they do that in an automated fashion. So you need to make sure that you lock things down. And hopefully this session gave you a little bit of awareness of where to look and how to do that, or at least have the conversations with your security team so that you can manage that. Okay, thank you very much. Take care, everybody.